How tornadoes form. Tornadoes are born from thunderstorms, especially a special type of storm known as a supercell. The recipe requires a mix of warm, moist air near the ground, usually fed in from the Gulf of Mexico in the US, and cool, dry air above, often moving down from the Rocky Mountains or Canada. The third critical ingredient is wind shear, which means winds blowing at different speeds and directions as you go higher into the atmosphere. This combination creates rotation inside a storm. Under the right conditions, that rotation narrows and intensifies into a funnel, the tornado. What's important to note is that tornadoes aren't like hurricanes. They don't cover hundreds of miles, and they don't draw energy from warm oceans. Instead, they are small-scale, violent whirlwinds tightly linked to storm dynamics in the atmosphere, not just what's happening on the ground. The scale of tornado power. To understand whether skyscrapers can stop a tornado, you need to appreciate just how powerful these storms are. Tornado wind speeds can range from as low as 65 miles per hour in a weak EF0 to over 200 miles per hour in a violent EF5. The strongest tornadoes can reduce entire neighborhoods to rubble, rip asphalt from roads, and toss vehicles through the air like toys. A large tornado can be more than a mile wide, stretching far beyond the footprint of any skyscraper. This scale makes it immediately clear that tornadoes are not fragile weather systems. They are colossal whirlwinds powered by forces high above ground level, and their energy is tied to the atmosphere on a scale that dwarfs any single building. Skyscrapers and their designed skyscrapers are feats of engineering, designed to withstand high winds, earthquakes, and in some cases, even plane impacts. Engineers carefully consider how tall towers will respond to powerful weather. They are built to flex slightly in the wind to release stress rather than snap. Their shapes are often sculpted to reduce the vortices and drag that swirling winds can create. They are anchored with steel and reinforced concrete that ensures they remain standing under extreme conditions. However, skyscrapers are designed with straight-line winds in mind, the kind that come from strong thunderstorms or even hurricanes. Tornadoes are different. Their winds swirl chaotically, shift direction within seconds, and can propel heavy debris at extraordinary speeds. That kind of violence is outside the usual calculations of skyscraper design. Do tornadoes hit cities? Interestingly, tornadoes rarely hit the downtowns of major cities. Part of this is simply probability. Cities cover relatively small areas compared to the vast stretches of rural land around them, so the chance of a direct hit is lower. But when tornadoes do strike urban centers, we see clear evidence that skyscrapers are not tornado-proof barriers. Dallas, Texas, for example, experienced a powerful EF3 tornado in 2019 that tore through the metro area, heavily damaging suburban neighborhoods. Downtown skyscrapers were untouched by sheer luck, not because they acted as shields. In Fort Worth in 2000, a tornado struck downtown, damaging high-rises, shattering glass, and injuring dozens. The buildings withstood the hit structurally, but they did nothing to stop or weaken the storm itself. And in Oklahoma City, one of the most tornado-prone areas in the world, the downtown core has so far avoided direct hits. Meteorologists agree, however, that if one occurred, skyscrapers would not protect the city in any meaningful way. Can skyscrapers stop tornadoes? Here's the short answer: no. Skyscrapers cannot stop tornadoes. The reason is straightforward. Tornadoes are powered by massive rotating updrafts extending thousands of feet into the sky. A few tall buildings on the ground don't affect the storm-scale dynamics happening far above. Even the tallest skyscrapers, like One World Trade Center in New York at 1,776 feet, are tiny compared to the vertical depth of a tornado's parent storm, which can extend more than 50,000 feet into the atmosphere. When tornado winds encounter buildings, the air simply flows around the obstacles. At most, the path of a tornado may shift slightly when encountering a cluster of tall buildings, but it will not dissipate. In fact, the narrow street canyons and reflective surfaces of urban skylines can sometimes intensify local turbulence and accelerate winds near ground level, making things even more dangerous. What actually happens? If a tornado hits a skyscraper, If a strong tornado collides with a skyscraper, several things can happen. Glass windows are the most vulnerable feature, and tornado winds will easily shatter them, sending dangerous shards flying into the streets below. Debris carried by the tornado becomes high-speed missiles that can puncture walls and destroy anything in their path. The skyscraper itself is unlikely to collapse. Modern engineering ensures that most tall towers would remain standing, though they would bear the scars of the storm. The more immediate danger would be at street level. Wind patterns swirling around the base of the building can create violent eddies that increase destruction to smaller structures nearby. For low-rise buildings and houses, being next to a skyscraper could actually worsen the impact, as debris ricochets and winds channel into narrow spaces. The myth of urban protection. There is a persistent myth that tornadoes somehow avoid cities or that downtown skylines act as shields. This belief is rooted in probability rather than science. Since cities occupy relatively small areas, tornadoes statistically hit rural regions more often, leading people to assume they are less likely to happen in cities. In reality, tornadoes are equal opportunity destroyers. When they do strike urban areas, they show no mercy. The skyscrapers lining downtown streets do not end them, weaken them, or deflect them. Rivers, highways, and other city features are equally powerless against a storm driven by atmospheric processes on such a vast scale. Could we build barriers to stop tornadoes? Some futurists and engineers have speculated about giant walls or artificial barriers to block tornadoes before they reach populated areas. The problem is scale. Tornadoes often span several miles wide, and they draw their energy from the atmosphere above, not just the winds at ground level. To build a barrier that could stop a tornado, it would need to be thousands of feet tall and dozens of miles long. Such a project is far beyond human construction capability. Even if it were possible, it would almost certainly disrupt weather patterns in unpredictable and dangerous ways. Instead of preventing tornadoes, it might create new weather hazards. The sheer impracticality of the idea shows why humans must adapt to tornadoes rather than attempt to physically block them. The real way to stay safe. Instead of hoping skyscrapers will block tornadoes, safety comes from preparation and technology. Weather warnings, powered by modern radar systems, now give lead times of 15 to 30 minutes before a tornado strikes. That window, while short, saves countless lives every year. Sheltering strategies are also vital. Underground storm shelters or interior rooms away from windows remain the safest places to be when a tornado approaches. For communities in tornado-prone regions, reinforced safe rooms are increasingly being built into homes, schools, and public buildings. These small, hardened spaces provide reliable protection against even the strongest tornadoes. The third layer of defense is stronger building codes. While we cannot design entire cities to withstand EF5 tornadoes, incremental improvements in materials and safe room construction make an enormous difference. Technology, awareness, and preparation are our true defenses against these storms, not the silhouettes of our tallest buildings.